This example is going to show you how to complete the square when you're given a quadratic equation. So we're starting with x squared plus 6x plus 3 equals 0. And we want to complete the square with the x squared plus 6x part. And this is some of the things that we started and we played with tiles. We just did it one class period. But we showed how we would, if we put all these tiles together, we would have an incomplete square. And then we developed a pattern of what happened when we filled in the tiles that were needed and then looked at what the side lengths were, our product form, to make that sum. And we found out that we had a pattern that if we took that middle term, 6x, we divided it by 2 and then squared it, that we actually were able to complete the square with our tiles. We found that pattern through that. So it was a really interesting discovery that helps us to do a really easy process at this point. So completing the square is actually more powerful when you want to graph a parabola, but you can also use it to solve. So this example is going to be used to solve for x given a parabola. And there's no coefficient in front of the x squared, so it's actually easier to complete the square with this type of example than if we were to throw a number such as 2 in front of the x squared, which we have to make sure that we're getting the product of what we do, just a little bit more work and a little bit more attention to detail that you have to look at. So for this one, we're going to complete the square for the x squared in the x terms. And we're going to take that positive 3, and we're going to bring it over the other side so that we're not muddling it up on the left side. So when I do that, I have this x squared plus 6x. I'm going to complete the square by adding a number there on the left side. So I'm putting a space so I know there's a number that's going to go there. And when I subtracted 3 to both sides, I have negative 3 plus, I added another space. Because if I add something to the left side of my equation, as we know, to keep balance in our equation and not change that actual value of that equation, we need to add the same thing to the right side. So whatever you do to one side, you must do to the other. So I put those spaces in there just to remind me that when I add that number to complete the square to the left, I've got to also do it to the right. So I'm going to take the middle term, 6x, I'm going to divide it by 2, that gives me 3. And now I'm going to square it, which makes sense. I'm asking you to complete the square, so I need to find a perfect square. What we're actually finding here is what number is going to be a perfect square that's going to multiply by itself, but add to get that middle number. So when we think about how we factored our diamonds, we always said what multiplies to get that c term and adds to get that middle term with the x. That's all we're doing here, but we want the number that you're multiplying by itself. So that's what this completing the square helps us find. So we have 3 squared is 9, so 9 is actually going to go into those 2 spaces. That's the number that completes the square. So I'm going to put them in, looks like that. And now I'm going to write it as a factor. So when I factor x squared plus 6x plus 9, the number that multiplies to get 9 is 3 and adds to get 6. Okay, so 3 times 3 is 9, 3 plus 3 is 6. We don't have to rethink the factoring. If you look at that 6 divided by 2 is 3, that's the number that always is going to be in our factored form. So I have x plus 3 squared. And then on the right side, notice that negative 3 plus 9 is 6. So that's how I came up with the equation of x plus 3 quantity squared equals 6. So now we can go ahead and solve this with our methods by undoing everything to get to the x. So we're going to look at that x plus 3 squared. To undo that squared, we take the square root. Now when I put that square root in with the 6, remember I'm putting it in, so I have to account for the plus or minus. That's why you see that in there. The squared and the square root on the left cancel each other out and leaves me with just x plus 3 inside that radical. So I have x plus 3 equals plus or minus 6. Subtract your 3 from both sides. So you have negative 3 plus or minus root 6. This is the exact answer form. You don't need to put it in a decimal approximation unless you need to use that number for something else. So we're just going to leave it like this. And if I gave you a test and said, leave it in exact form, no decimal approximations, this is what I mean. That's it for completing the square. Thanks for watching.